Okay, this begins, the lecture is going to replace where, I canceled class today. And what we're actually beginning today is two variable statistics. And the way I want you to think about two variable statistics, and the way we usually refer to this, is correlation and linear regression. Now, for the most part, there are three parts to the process. The first part is what we call correlation. The second part is called the regression, and the third part is are the residuals. Now, I want to break this down and tell you what each part does for us and what I intend to teach you. The first part today, what I'm going to try to do is just get through the correlation aspect. And we'll try to keep this lecture at about 15 to 20 minutes. So, again, that's the intent. So, the first part here, dealing with correlation, the purpose is to measure the strength of the relationship between two quantitative variables. Guys, keep in mind that this process doesn't apply for categorical variables, so I'm going to underline that just to make a point of that. The second part of the process, regression, this part is used for prediction. And ultimately what we try to do here is we want to fit a linear model to our data which best explains the linear relationship. Now, if you're paying attention, you know there's something going on here with linear. This process only works with relationships that are linear, and I'll point out just in a second the difference between a linear and nonlinear relationship. Because the final thing I'm going to teach you probably won't come until next week are the residuals, and this part of the process, this part tells us or addresses the question, is a linear relationship appropriate for describing yeah, is a linear let me change that. That didn't like the way. Yeah, I've only had one cup of coffee, so I'm still trying to wake up here. So residuals, is a linear model appropriate for describing the relationship between the two variables? So, gang, that's what we've got in store. This will be the last thing that we'll do before your first exam. This part usually takes somewhere between 2.5 weeks. I tell my students all the time that when first learning correlation regression, it's equivalent to, or at least it feels like you're trying to eat a 500-pound marshmallow in one bite. There's going to be a lot going on here, but I think the way I teach it in the end kind of simplifies this. Now, this lecture, what I intend to address is the correlation aspect. And the correlation aspect, there's going to be three parts of it, as you may expect, or maybe not. The first part is look at a picture. And the picture that we look at in this situation for the two variable statistics is called a scatter plot. Now, in one variable statistics, we would look for quantitative variables. We would look at a histogram or box plot. Again, the histogram would give us the shape of the distribution. The box plot would give us provide the 5-number summary and identify outliers. The next thing we're going to want to do is look at the numerical summaries. And just like we did in quantitative data when we came up with measures of center and spread with the mean, the median, standard deviation, quartiles, and so on and so forth, the numerical summaries give us that one number that illustrates important characteristics of our data, of our relationship. The two that we look at here, this first one is going to be the correlation coefficient. And the second one is the coefficient of determination. And guys, this one is given as r squared. Again, these are going to be two numbers that will give us important, important characteristics of the relationship between the data. Now, what I want you to do, you may want to pause this video now, and I want you to go into my stat lab. And I'm demonstrating this for the 9 a.m. class, but it's the same thing for the 9:30. If you go into under Course Tools and go to Document Sharing, you'll have a data set there called Data for LR. That just stands for Data for Linear Regression. I want you to open that up, save it to your desktop, and then come back to the lecture. Now, if you're back with me, the data set that we have here includes some information on different makes and models of cars, and these are all European cars, and we have the volume, horsepower, miles per gallon, the top speed, and the weight. Now, what I want to examine here is for this illustration. Let's examine the relationship between, let's see, what did we do here? Let's look between horsepower and miles per gallon. So the kinds of questions that we would want to ask here, first question. Is the relationship linear? Is the relationship positive or negative? Is the relationship strong, moderate, or weak? Now, guys, again, standing, seeing the bigger picture here. These three questions right here are addressed with the correlation aspect. The regression aspect, the residual aspect, those come in later. The purpose of this video is just to address the correlation. Now, what I've done for this illustration is I've gone ahead and entered the data into the calculator. So if we go to Stat and go to Edit, you can see in L1 and L2 that I've entered my data. So I entered horsepower in L1 and I entered the miles per gallon in L2. So again, you might want to pause the video, carefully enter that data into L1 and L2, and I'll come back to this calculator when we do certain calculations. Okay, now the first thing, I want to go to the air server for this. The first thing is to understand a little bit about relationships. First of all, I mentioned that was smooth. I mentioned a linear relationship. And I'll just refer to that here as a linear model. Guys, a linear model is one where we have sets of data, and we think about the horizontal being x and the vertical being y. A linear model would be something that would look like this, where the points tend to be in a linear fashion. A good way of looking at this is if we draw a line through the central part of our data, we get a straight line. A nonlinear relationship, as you probably would imagine, would be something if we have data that would look like this. You don't have to have a PhD in mathematics or statistics to see that a linear model does a horrible job of modeling this relationship. So we would want something more of a nonlinear model for this because of the shape of and the pattern of the data. So gang, what we're focusing on is this data right here. Okay? Now, the next thing we get into after is a relationship linear. Is it positive or negative? Well, this goes directly back into the definition of slope. If we have a positive slope, in other words, if a line is positive, it rises to the right. So if we have data that rises to the right, where this line that we draw down through the central focus of our data rises to the right, then we have a positive relationship. As you would expect, if the opposite happens, and our relationship goes from left to right but falls off to the right, examine the relationship there with the straight line, pretend that's straight, then we have a negative relationship. Now, let's go back to our data, and what we have is we want to be able to examine the relationship between a car's horsepower and miles per gallon. So what are we expecting here? What kind of relationship? Well, if you think about it, as we increase horsepower, do we expect the miles per gallon of the car to get smaller or larger? So let's say, for example, that we've got some data collected down here for cars with lower horsepower. Does it make more sense that cars with lower horsepower have higher miles per gallon or lower miles per gallon? Well, think about a car that's like a Hummer, a lot of horsepower. Would you expect the Hummer to have more miles per gallon or less miles per gallon? Well, to me, this one doesn't make sense. I'm expecting a car with less horsepower. That's not. Let me back up here. I'm expecting a car with less horsepower to have a higher miles per gallon. So I put the X to the other. Now, as we increase the horsepower and let a car have more and more and more horsepower, what do we expect to happen to the miles per gallon? Well, I would expect the miles per gallon to decrease. So without examining the data, I'm expecting to have a negative relationship here because I'm expecting cars with higher horsepower to get less miles per gallon. And again, I don't know that, but that's why we collect data and we examine problems like this. Now, the next thing we get into, and remember the three questions: is our relationship linear? Is it positive or negative? And do we have a strong, weak, or moderate relationship? Well, and we'll give you an example of all of these on the same drawing. When we collect our data and we look at a scatter plot, which again I'll teach you how to do in just a second, if we imagine this line going down through the central focus of our data, if there's not much variation away from this line, then we refer to this as a strong relationship. As the variation increases, further away from this line, then we would refer to this, as a moderate relationship. When we get data that's spread quite a bit away from our line, significantly so in this situation here, then we refer to this as a weak relationship. Okay? Now, what I want to do very quickly, I want to show you how to prepare a scatter plot using your calculator. So let's go back to the calculator. Don't you love the picture of me throwing the football to my daughters? So it shouldn't surprise you that to construct a scatter plot, we go to stat plot, just like we did to get box plot and histogram. I want to make sure that plot 2, 3, and 4 are turned off. If it's not the case, if one of these are on, then we need to go to number 4, turn our plots off, and then go back into plots off. Go back into stat plot. But my 2 are turned off. I got on, so I'm going to hit enter. First thing I need to do is make sure it's turned on. Next thing I need to do is come down and choose the appropriate icon. Well, the scatter plot the icon for scatter plot is this one right here. So I need to hit enter and select it. Now the next thing I do is come down and select which is my X and which is my Y. There's a little bit of a trick here. The one that's X is the one that comes first. And if you think about rolling a car off the assembly line, that car has an established miles per gallon and a horsepower. So neither one naturally comes first. Let me give you an example where it would make a difference. Let's say we wanted to be able to predict or to model, if you will, explain the relationship between a son's IQ and a father's IQ. Well, clearly the father's IQ would come first and the son's IQ would come second. So the father's IQ would be X and the son's IQ would be Y. So if there's a natural ordering of the two variables, the one that comes chronologically first will be the X, the other will be the Y. If that doesn't happen, as in our case, what we have to do is just decide which one we want to be able to predict in terms of the other. So let's say, for example, and let me go back to our document, that our goal to predict miles per gallon from horsepower. Guys, whatever variable we want to predict, that will always be our Y. And we refer to this as the dependent variable. The other variable that we're predicting from is referred to as our X, which is our independent variable. Your textbook recalls this the response variable and calls this one the explanatory variable. So just keep that in mind. The goal, the variable that we're trying to predict is our Y, dependent variable, response variable, and the other is our X, which is our independent variable. Okay, keeping that in mind, what I have here is my X list. I want that to be horsepower, which I put in L1. So hit my second function key, hit my 1 key, and I want my Y list to be L2. Okay, so I've got that second function key locked, so I need to go back up to the top before I hit zoom stat. So I'm just going to hit zoom, number 9. And guys, as I expected, I have a negative relationship. Okay. Now, next thing when I look at this is the relationship linear? Do I have any nonlinear tendencies? And I can visualize a straight line coming through the data which reasonably explains the relationship. So I don't have any, I have no concerns with linear. Second thing, positive or negative, this one is clearly negative. And the strong, weaker, moderate component, what do you think? Well, the data, especially down in here, is spread out quite a bit. So I don't think it's spread out enough to be weak. It's certainly not a strong relationship. So what I would assume, or what I would conclude here, I would conclude the relationship between horsepower and miles per gallon is linear, negative, and moderate. So guys, that's all for this video. There'll be I'll probably put up 2 more videos today, but I want to keep these things small so it makes it easier to upload to YouTube. So that's the end.